Hey, beautiful and amazing keen science learners. In today's science video, we'll quickly go through some of the very exciting and cool properties of Becquerel radiations, that is, alpha, beta, and gamma. It was none other than Rutherford and Villiers who were the first to analyze the radiation emitted by radium. They had a simple experimental arrangement to demonstrate the analysis of Becquerel radiation into three components. A small hole was drilled in a lead block and a piece of radium was placed at its bottom. Since the rays entering the walls of the lead block were absorbed before reaching the surface, only a narrow beam of radiation emerged from the hole. The beam was further subjected to the electric or magnetic field. In both cases, the narrow beam splits into three components. The component that bends towards the right consists of positively charged particles called alpha rays, and the component that bends towards the left consists of negatively charged particles called beta rays. The component which goes straight consists of neutral photons called gamma rays. Let's see the properties of alpha rays. These are positively charged particles. These particles have been identified as helium nuclei. They are deflected by electric and magnetic fields. The velocity is one-tenth of the velocity of light. They excite fluorescence. Also, they can affect a photographic plate. They ionize heavily the gases. Also, they are easily absorbed by matter. They are scattered while passing through thin metal sheets. They can cause artificial disintegration of an atom. Also, they can cause heating effect to a human body. The range of alpha particles in air may varies from 2.7 centimeter to 8.6 centimeter. They consist of fast-moving electrons and are deflected by electric and magnetic fields and are emitted with velocity as high as 99% of the speed of light. They excite fluorescence, affect a photographic plate, ionize a gas with 1 by 100 times that of alpha rays. Penetrating power is 100 times that of alpha particles. They can penetrate aluminum foil of 5 mm thickness. The range is much more than that of alpha particles. The emission of a beta particle is always accompanied by the emission of an elementary particle called neutrino. Let's see the properties of gamma rays. They are electromagnetic waves, wavelength less than that of X-rays. They are not deflected by electric and magnetic fields, since they do not carry any charge. They travel with the speed of light. They excite fluorescence in substances. They affect a photographic plate. Their ionizing power is 1 by 10,000 times that of alpha rays. Penetrating power is about 10,000 times that of alpha rays. They can even penetrate a 30 centimeter thick iron block. They eject beta particles from substances on which they fall. They show the phenomenon of pair production.